Hi, pals. In this very lesson, we're going to be solving the fifth and the final question we are given as a take home in our previous lesson on circular motion. So, before we solve this very question, if you want to give it a try, I'll give you some time to do that. Okay, let's see if you're one of those who solved this very question correctly. So, what do we have right here on the board? The human body can safely stand 9 times the acceleration that is due to gravity. With what minimum radius of curvature may a pilot safely turn a plane at the end of a dive if the speed of the plane is 770 kilometer per hour? Now, this question is very simple, and you just need to be quite creative with it. So, what are we talking about here? A pilot that is flying a plane and he's trying to turn the plane at the end of a dive with the speed of 770 kilometer per hour. So, what would be the minimum radius of curvature? Now, the question is, what will help the plane to move through this, this circular path? What will help the plane to move through this very circular path is the weight of the plane alongside the weight of the people in it. So that means you're going to be talking about weight. Weight will bring about the centripetal force. Don't forget, centripetal force is the same thing as radial force or angular force. So that's what we have. So weight is mass times gravity. No, we are not told the weight of the people in it. We are not told the weight of the plane. Just assume there's a weight, which is mass and gravity, equals to this. The centripetal force is mass mv squared I over mass times velocity, that speed of the flying object, squared over radius. So mass takes up mass. We have gravity equals to v squared over radius. This is what we have. So now don't forget, the human body can safely withstand, or stand for short, 9 times the acceleration that is due to gravity. So it means the human body can withstand 9 times, acceleration due to gravity. So that will be, so the gravity is going to be 9g. Don't forget that gravity is a constant 9.81 meter per second, squared. That's gravity. So this 9g, that's 9 times acceleration that's due to gravity. So what's the velocity? The velocity is 770 kilometer per hour. Now, since gravity, acceleration due to gravity is a meter per second squared, we can't use kilometer per hour. So we're going to use the MKS system. NKM system is a meter, kilogram, and second. So we're going to convert the 770 kilometer per hour to meter per second, which is the official unit for velocity. So how do we do that? 770 kilometer over 1 hour. The kilometer will be moved to meter. The hour will be moved to seconds. 1,000 meter is what we have in 1 kilometer. So 770 kilometer is going to be 770 times 1,000. Now, how many seconds do you have in 1 hour? We have 3,600 seconds in 1 hour. So we're going to divide that by 3,600 seconds. So we're going to divide, 0 takes out 0, 0 takes out 0. So we can use our calculator to finish up this. Quickly, let's do that. We have 770 times 10 divided by 36. So right here we have 213.888. So we have 213.9 meter per second. That's what we have right here. So we're going to be using this velocity, to solve this. So don't forget, the body can withstand 9 times acceleration that is due to gravity. So that's 9g equals to velocity, the new velocity, 213.9 raised to power 2 over the radius of curvature we are looking for. This is what we are looking for right here. So what is gravity? Gravity is 9.81 meter per second squared. So 9 times 9.81 equals to 213.9 squared divided by radius. This is what we have. So what do? We're going to cross multiply. We're looking for radius. So it means the radius of curvature will be equals to 213.9 raised to power 2 divided by 9 times 9.81. So quickly, let's use our calculator to finish this up. We have the 213.9 squared divided by 9 times 9.81. That will give us 518.215. So that is 518.2. That is the radius of curvature that we have, that's in meters. As simple as ABC. So the human body that can withstand this 9 times the acceleration that's due to gravity, the radius of curvature that the pilot has to go through to be able to, turn this very plane is 518.2 meter. So as simple as that. So that's everything for the very lesson, and we've come to the end of everything on circular motion. And don't forget, after this, the next thing you're going to be moving on to will be simple harmonic motion, which is the next part of the two-dimensional motion. So if you found this lesson very helpful or resourceful, please subscribe to this very channel at Edge Mosaic and follow me at Revelation Hub on Facebook and share this lesson also with others. See you in the next lesson. Bye for now.